2:17 a.m. Fujian Province, eastern coast of China. Inside a reinforced tunnel complex carved into the granite hills above the strait, the first transporter erector launcher rolled to its designated firing position. The process had been rehearsed 11 times in the preceding 18 months. On each occasion, the TAL had reached firing position in 11 minutes and 40 seconds. On this occasion, with launch authorization already confirmed through the command chain, the crew had the vehicle leveled and the canister elevated in 9 minutes. The record was not celebrated. It was noted. At 2:17 a.m., the first DF-17 launched. The hypersonic glide vehicle separated from its boost stage at approximately 60 kilometers altitude, transitioned to a depressed glide trajectory, and began its terminal phase at Mach 5.4, a speed at which the aerodynamic heating envelope around the vehicle made radar cross-section measurement unreliable and intercept geometry calculations a problem of a different order than conventional ballistic threats. The DF-17 was not designed to travel in a straight line. It was designed to make straight-line intercept solutions geometrically impossible. Within 90 seconds, 14 additional DF-17 launches were confirmed from the same tunnel complex. Simultaneously, 3 separate locations along the Fujian and Zhejiang coastlines brought DF-26B intermediate-range ballistic missiles to launch posture. The DF-26B's 4,000-kilometer range placed Guam well within its engagement envelope. Its designers had named it the Guam Express. The name had not been chosen casually. By 2:31 a.m., the People's Liberation Army Rocket Force had placed 1,147 weapons in flight. The breakdown: 94 DF-17 hypersonic glide vehicles targeting Kadena Air Base in Okinawa and the Yokosuka Naval Facility. 312 DF-26B intermediate-range ballistic missiles routing toward Andersen Air Force Base and Naval Base, Guam. 287 DF-21D anti-ship ballistic missiles with terminal guidance packages optimized for moving maritime targets, aimed at the 2 carrier strike groups operating in the Philippine Sea. 198 DF-100 supersonic cruise missiles targeting U.S. logistics and air defense infrastructure across the Ryukyu chain. 156 YJ-21 hypersonic anti-ship missiles launched from PLAN surface combatants and H-6N bombers operating at standoff range over the South China Sea. The target architecture was coherent and had been under continuous refinement for 14 years. Kadena's runway complex represented the only U.S. air base within unrefueled tactical fighter range of the Taiwan Strait. Andersen and the Guam complex represented the primary long-range strike platform for any U.S. response in the Western Pacific. The 2 carrier groups were the mobile firepower that could not be fixed to a geographic location. Their operating positions had been tracked by Yaogan constellation overhead imagery and Type 093 submarine passive sonar for the preceding 11 days. The plan understood where those ships were. They had built 287 missiles specifically to reach them. This was the opening sequence of a Taiwan Strait operation. The logic was not that these strikes would end U.S. involvement in the Western Pacific. The logic was that they would create a 72-hour window of suppressed U.S. offensive capability, during which a cross-strait operation could achieve sufficient facts on the ground that the political cost of U.S. re-engagement would exceed the threshold of congressional authorization. The 72-hour calculation had been presented to the Central Military Commission 3 times in the preceding 5 years. The most recent confidence interval, 74%. The flaw was not in the targeting. The targeting was accurate. The flaw was in the resilience modeling. The plan's assessment of U.S. recovery time had been built on platform-level attrition. How many Patriot batteries? How many Aegis cells? How many runway repair crews? It had not adequately modeled the degree to which the U.S. force in the Western Pacific had been specifically reoriented over the preceding 8 years around exactly this scenario. Distributed operations, prepositioned assets, redundant logistics chains. The force the plan's model described had existed in 2016. The force it was now engaging had been redesigned in direct response to the model the plan had used to build its missiles. 2:18 a.m. Buckley Space Force Base, Colorado. The SBIRS constellation had been tracking rocket force activity for the preceding 40 minutes. TEL diesel engine thermal signatures, launch control system electromagnetic profiles, vehicle movement patterns that matched no exercise in the historical database. The watch officer had flagged the activity to Indo-Pacific Command at 1:41 a.m. as a probable preparation for launch indicator. The word probable was removed at 1:58 a.m. when the 5th TEL complex showed simultaneous power-up signatures across 3 separate provinces. The first launch plume registered at 2:17 a.m. The automated correlation engine identified it as a DF-17 boost phase in 0.3 seconds. The watch officer confirmed and initiated the launch notification chain before the DF-17 had cleared its complex. He had been in this chair for 7 months and had processed one previous high-confidence launch event. This notification took 2.8 seconds from confirmation to receipt at Indo-Pacific Command. 1,447 aim points were simultaneously in flight. Indo-Pacific Command's Joint Operations Center in Hawaii received the notification at 2:17 a.m. The Battle Watch captain had already been at elevated alert status for 9 hours. The Aegis destroyers and cruisers spread across the Philippine Sea, the waters east of Okinawa, and the approaches to Guam had been in a heightened sensor state since 1:50 a.m. when the satellite intelligence assessment had upgraded to imminent launch probability. 3 of the 6 Aegis combatants assigned to Kadena Area Defense had their SPY-1 radars already in full active search mode, painting the horizon at maximum pulse repetition frequency. The first cooperative engagement capability targeting solutions were generated at 2:19 a.m., 2 minutes after the first DF-17 launch. The intercept geometry for the DF-17 was the critical problem. A conventional ballistic missile follows a predictable parabolic arc. An interceptor assigned to it can be calculated against a predicted intercept point along that arc. A hypersonic glide vehicle operating at Mach 5+ on a depressed trajectory does not follow a parabolic arc. It maneuvers. Its altitude band sits below the optimal SM-3 Block 2A engagement envelope, but above the terminal phase where PAC-3 MSE operates most effectively. The intercept window, the narrow altitude and time corridor in which the threat could be engaged at acceptable probability, was approximately 40 seconds per vehicle. 40 seconds at Mach 5 is a corridor approximately 120 kilometers long. The SM-6 Block 1, with its active seeker and terminal maneuver capability, was the designated tool for the DF-17 threat band. Its engagement geometry required precise sensor cueing from the Aegis Spy-1 network. Under CEC, multiple ships contributed tracking data to generate the targeting solution. The SM-6 did not need to be launched from the ship generating the best track. It could be launched from the ship with the best intercept geometry and guided by the ship with the best track. That distinction had been the subject of 6 years of development work and 4 fleet exercises. This was the operational test. By 2:24 a.m., 67 SM-6 launches had been executed against the DF-17 package. Intercept probability for each engagement was modeled at between 51% and 68%, depending on engagement geometry. This was not the 90+% engagement probability that characterized SM-3 engagements against conventional ballistic missiles. The DF-17 was a harder problem. The system knew it was a harder problem. Of 94 DF-17 vehicles, 61 were intercepted or sufficiently disrupted to miss their intended aim points. 33 reached their terminal phase. Of those 33, 19 were engaged by PAC-3 MSE batteries at Kadena and in the Yokosuka Defense Network at terminal phase. 12 were neutralized. 7 impacted within their aimpoint zones. 3 hit the Kadena runway complex, 2 in the primary runway surface, and 1 in the parallel taxiway. 2 impacted the Yokosuka waterfront area, 1 striking a pier facility, and 1 impacting in the harbor basin. 2 impacted Kadena's fuel storage infrastructure. Kadena's primary runway, operationally degraded. Not neutralized. Degraded. The runway repair teams had pre-positioned their equipment and supplies as part of a resilient airbase concept implemented 22 months prior. The first runway repair crews were on the surface within 8 minutes of the final impact. Initial assessment: primary runway operational within 90 minutes. Parallel runway operational within 4 hours. This was not the 72-hour suppression window the plan's model had projected. The DF-26B packages routing toward Guam presented a different intercept geometry. Longer flight time. Mid-course phase, accessible to SM-3 Block 2A from Aegis combatants pre-positioned east of the Marianas. The THAAD battery at Andersen had been fully operational and in full active sensor mode since 1:52 a.m. The 312 inbound DF-26Bs were distributed across multiple approach vectors specifically to saturate the THAAD battery's engagement rate. An accurate assessment of THAAD's individual throughput capacity. What the plan's model had not fully incorporated was a second THAAD battery emplaced on Guam 14 months prior, not yet reflected in open-source assessments. The 2 batteries, networked through CEC with 3 Aegis combatants to the north and east, functioned as a distributed area defense network with a combined engagement rate that exceeded the plan's single battery saturation calculation. By minute 22, the United States had expended $2.1 billion in interceptors and precision munitions. Still accelerating. Of 312 DF-26Bs, 241 were intercepted in mid-course or terminal phase. 71 reached their target areas. Of those, 44 were engaged by PAC, 3MSE, and CIWS at terminal phase. 27 impacted across the Guam complex. Andersen's primary runway received 4 impacts, temporarily non-operational. The naval base received 3 pier infrastructure impacts. 5 impacted in non-critical areas. Andersen non-operational for an estimated 4 to 6 hours, not 72. At 2:29 a.m., the anti-ship ballistic missile packages began entering terminal phase against the 2 carrier strike groups. The CSG commanders had received launch notification at 2:18 a.m. and had immediately executed evasive maneuvering doctrine, the carrier itself beginning a series of course changes that would, over the following 18 minutes, displace its position from the plan's last confirmed fix by approximately 34 kilometers. The DF-21D's terminal guidance was designed to compensate for ship movement. It could compensate for movement within a search corridor. The question was whether the carriers had moved outside that corridor. The first carrier had moved 27 kilometers. Inside the DF-21D's search corridor, of 143 DF-21Ds assigned to the first carrier group, 89 were intercepted by SM-3 and SM-6 launches from the group's 4 Aegis escorts. 31 were neutralized by PAC, 3MSE, and CRAM at close range. 23 entered the terminal search phase. 19 failed to acquire. The ship's displacement and signature management combined to put 12 outside the Seeker's acquisition cone, and 7 were defeated by CYWS and decoy systems. 4 acquired the carrier. 1 was intercepted by CIWS at 180 meters. 1 impacted the flight deck. 2 impacted the waterline area. The USS Gerald R was not sunk. A 1,500-kilogram kinetic impactor hitting an armored flight deck at Mach 8 does not sink a 100,000-ton vessel. It disables flight operations. The flight deck impact created a 12-meter crater, ruptured 2 fuel lines, and severed 3 arresting gear systems. The waterline impacts created flooding in 2 forward compartments, contained by damage control teams within 11 minutes. The carrier was combat effective at approximately 40% of its normal flight operations capacity. The second carrier group had displaced 41 kilometers outside the DF-21D's primary search corridor. Of 144 assigned DF-21Ds, 138 were intercepted before terminal phase or failed to acquire in terminal search. 6 reached CIWS range. All 6 were neutralized. No impact. USS Gerald R. Ford was the only capital ship hit. It remained operational. The USS Leyte Gulf, a Ticonderoga-class cruiser assigned to the Ford's escort, had expended 94 of 122 VLS cells in the preceding 18 minutes. She transmitted her threshold status at 2:36 a.m. The CEC network redistributed her remaining intercept assignments across 3 other Aegis platforms with surplus capacity. The redistribution took 6.1 seconds. During those 6.1 seconds, Track 1847, a YJ-21 hypersonic anti-ship missile launched from an H-6N bomber 800 kilometers to the southwest, was momentarily unassigned. It was reassigned to USS Bunker Hill, which engaged it at 94% of maximum SM-6 range. Intercept probability at that range, 63%. The intercept succeeded. But Leyte Gulf's threshold had been reached. She would not be the last. The scale of the planned salvo was designed to exhaust VLS capacity across the entire Aegis network, not at any single ship, but cumulatively. Of the 14 Aegis combatants in the theater, 3 had reached below 15% VLS capacity by 2:41 a.m. The system was deep, but this was a different category of pressure than the Iranian scenario. This was a pier-level force specifically engineered to find the bottom of the magazine. The counter-operation was not a 60-minute clean conclusion. This was the first 60 minutes of a longer campaign. But within those 60 minutes, certain things had been decided. At 2:22 a.m., while the defense was still processing the first waves, the offensive response sequence activated. Operation Chainbreak had been in pre-planned status since 2019, revised 17 times, and was designed specifically for the first 60 minutes response to a plan rocket force salvo. It did not attempt to replicate the Iranian scenario's systematic dismantling of an adversary's complete military infrastructure. The plan's military infrastructure was too large, too dispersed, and too hardened for a 60-minute decisive response. What Chainbreak targeted was the PLARF's reload and relaunch capability, the TEL complexes, the missile storage tunnels, the fuel infrastructure, the mobile command posts. The objective was not to end the conflict. The objective was to ensure that a second salvo of equivalent scale could not be generated. B-2 Spirit aircraft already airborne from Whiteman Air Force Base on extended patrol received their final target packages at 2:24 a.m. Each carried JASSM-ER at standoff range and GBU-57 for hardened tunnel complexes. 4 Virginia-class submarines pre-positioned in the Philippine Sea and west of Guam received Tomahawk firing orders at 2:23 a.m. The first BGM-109E launches were confirmed at 2:24 a.m. Within 8 minutes, 164 Tomahawks were in flight toward PLARF, fixed infrastructure, launch complex surface facilities, fuel depots, maintenance complexes, communications relay nodes. The first JASSM-ER impacts on the Fujian Coast PLARF complex were confirmed at 3:11 a.m. Each JASSM-ER carries a unit cost of $1.36 million. 72 were assigned to the Fujian and Zhejiang target set alone. $97.9 million of U.S. precision munitions inbound on a single coastal complex. By minute 38 of the engagement, the United States had expended $3.4 billion in munitions and interceptors across the theater. The number was unprecedented in post-1945 U.S. military operations. The invoice was noted, logged, and forwarded to the appropriate planning authorities. Operations continued. EA-18G Growlers operating at standoff range from bases in Japan and from the carrier air wing provided continuous electronic suppression of PLAN radar networks. AARGM-ER launches targeted HQ-9 and S-400 battery fire control radars across the Eastern Theater. By 3:04 a.m., 14 of 19 cataloged long-range SAM fire control radars had lost continuous emissions. U.S. cybercom operations against PLARF command and control infrastructure had been active since 2:20 a.m., targeting fiber and satellite relay nodes connecting Rocket Force regional command centers to their TEL units. By 3 a.m., PLARF communications were estimated at 55% of normal capacity. Degraded, not severed. The 90-minute and 180-minute projections were lower. At 3:14 a.m., the plan executed its reserve. The CMC had held back a package of 48 DF-17 vehicles and 33 YJ-21 hypersonic anti-ship missiles from the opening salvo. A second wave timed to arrive when the U.S. Defensive Network's VLS capacity had been depleted by the first wave. The timing calculation was accurate. 3 Aegis combatants were below 15% capacity. 2 were below 10%. The second wave was designed to exploit those gaps. SBIRS detected the reserve launches at 3:14 a.m. The response adaptation was not in the playbook that the plan's model had used. 3 F-35Cs from the Ford's air wing, operating at reduced capacity due to the flight deck damage, but still able to launch from the undamaged forward section, were already airborne on combat air patrol and were vectored to intercept the DF-17's second wave at boost phase before the glide vehicles separated. The F-35C's AN/APG-81 AESA radar could track the DF-17 boost phase signature, and the AIM-120D, fired at the ascending boost vehicle before separation, created an intercept geometry that the DF-17's terminal maneuvering capability was not designed to defeat. The boost vehicle was not maneuvering. It was climbing. 19 of the 48 second wave DF-17S were intercepted at boost phase by the F-35C package, a capability the plan's model had assessed as low probability because it required a functional carrier air wing in the engagement zone. The carrier had been hit. The air wing had not been assessed as still capable of generating combat sorties at the time of the reserve launch. The assessment had not accounted for the carrier's crew. The remaining 29 second wave DF-17S entered their glide phase. The rebuilt intercept queue, redistributed across the Aegis network, engaged them with the same geometry as the first wave, but with significantly reduced VLS capacity. 21 were intercepted. 8 reached terminal phase against Kadena and the Yokosuka approaches. PAC-3 MSE neutralized 6. 2 impacted. 1 in the Kadena repair zone already under construction. 1 in the harbor approach channel at Yokosuka, impacting in water. The 33 second wave YJ-21s were engaged by the distributed Aegis network and by CIWS on the surface combatants at close range. 26 were neutralized. 7 reached terminal acquisition phase. 4 were defeated by CIWS and decoy systems. 3 impacted surface combatants. USS Bunker Hill took 1 impact on her bow section, flooding 1 forward compartment. 2 Arleigh Burke destroyers each received 1 impact on their superstructure. 3 U.S. surface combatants were now in damage control status. All 3 remained underway and combat capable at degraded capacity. None had been rendered non-operational. At 3:31 a.m., the PLARF command network processed its first comprehensive damage assessment from the Fujian and Zhejiang complexes. The assessment, arriving through degraded communications at approximately 55% of normal data throughput, was incomplete. What reached the command node was sufficient to indicate that the U.S. counter-operation had located and was engaging the TEL complexes and tunnel infrastructure that represented the rocket force's reload capability. The second salvo had been fired. A third salvo of equivalent scale was not achievable within the 72-hour window the operational plan had required. At 3:44 a.m., the CMC was informed. The 72-hour window assessment was revised, not because the plan had been defeated, because the U.S. system had not performed according to the model. Kadena was degraded, not neutralized. Andersen was degraded, not neutralized. The Ford was operational at reduced capacity. The counterstrikes were reaching the TEL complexes. The 72-hour window, the operational premise for the cross-strait movement, no longer existed as a planning assumption. 4:02 a.m. The carrier flight deck, USS Gerald R. Ford. The damage control team had contained the flooding. The flight deck repair crew had filled the primary crater with pre-positioned composite material and re-established the number 1 and 2 arresting wires. The forward catapults were operational. The carrier was generating strike sorties again, not at full capacity, but at 60% and climbing. The flight deck supervisor, a chief petty officer with 19 years of service, watched the first repaired deck aircraft launch into the pre-dawn darkness and noted the time in his damage control log. 53 minutes had elapsed between the impact and the first subsequent launch. He filed the entry and moved to the next item on his repair assessment sheet. There were 11 more items. The machine had absorbed the hit. It had not stopped. 4:19 a.m. Joint Operations Center, Indo-Pacific Command, Hawaii. The theater assessment display showed the status of 247 operational elements across the Western Pacific. The flag officer responsible for the theater's defensive response watched the display update. His planning team had spent 3 years building the distributed resilience architecture, now performing in live conditions. He had 3 damaged surface combatants and 1 damaged carrier. He had a rocket force second wave that had not achieved its intended effect. He had B-2s with remaining ordnance inbound to the second PLARF infrastructure wave, and 4 Virginia-class submarines with reload capacity. He had a theater that was still coherent. 3 damaged ships, 1 carrier at 60% capacity, 2 temporarily degraded air bases in reconstitution. Not the clean success the model suggested. Messy, costly, genuinely dangerous in several moments. But it had held. The adversary had fired everything in its first 2 waves. The U.S. had absorbed both and was still generating operational output. That was not the war the plan had modeled. Time from first PLARF launch detection to completion of initial U.S. counterstrike sequence against PLARF infrastructure. 57 minutes. Adversary missiles launched. First wave, 1,147. Intercepted or neutralized before structural impact, 891. Intercept rate, 77.7%. Second wave launched, 81. Intercepted, 54. Impacted, 27. Combined intercept rate across both waves, 77.9%. U.S. physical impacts received. Kadena runway, 5 impacts. Temporarily degraded. Reconstitution in progress. Andersen, 4 impacts. Temporarily non-operational. Estimated 4 to 6 hours to runway operational status. USS Gerald R. Ford, 3 impacts. Flight operations at 60% and recovering. USS Bunker Hill, 1 impact. Combat capable at degraded status. 2 Arleigh Burke-class destroyers, 1 impact each. Combat capable at degraded status. Yokosuka Harbor approach, 1 water impact. No structural effect. Counter-operation munitions deployed through first 57 minutes. 164 Tomahawk cruise missiles. 72 JASSM-ER. 4 GBU 57 MOP. 89 JDAM and small diameter bombs. 28 AARGM-ER. Carrier air-wing precision releases, including F-35C boost phase intercept sorties. 211 weapons. Total munitions expenditure cost, approximately $3.4 billion. PLARF infrastructure assessed as engaged. 34 of 47 cataloged TL complex surface facilities. 19 of 31 fuel infrastructure nodes, 12 of 22 mobile command post last known positions, 8 of 14 active launch complexes. Estimated PLARF first wave missile inventory expended. 94% of confirmed ready stock for the DF-17 and DF-26B programs. Reconstitution timeline, dependent on tunnel complex survivability assessments pending further reconnaissance. 3 Aegis combatants at below 15% VLS capacity. At sea replenishment operations authorized and in planning. Leyte Gulf at 6% capacity. Removed from intercept queue. Repositioning for replenishment. Tomahawk magazine. 164 of approximately 290 available from pre-positioned submarine force expended in first 57 minutes. The adversary had bet on a 72-hour window. The U.S. defensive architecture had been specifically designed to deny it. The denial was not clean. 3 surface combatants in damage control. A carrier hit. 2 air bases degraded and in reconstitution. 14 Aegis magazines depleted at rates requiring weeks to restore, but the theater was still functioning. The PLARF had expended 94% of its confirmed first-wave inventory. Its reload infrastructure was under active engagement. The 72-hour window did not exist. The adversary had modeled attrition. Attrition assumes damage removes capability permanently. Resilience means damage removes capability temporarily. And the gap between what was hit and what stopped functioning is where the campaign is actually decided. The gap, in this case, was 53 minutes on a flight deck repair crew's stopwatch.